So what's different looking about this from yesterday? They're different trig functions. We have to write them the same. So we are going to be using our favorite little identities over there. I see a secant and I see a tangent, so I'm going to do the I-tan secretly thing. I am going to change this in terms of secant. So remember, tangent squared is going to equal secant squared minus 1. So on the next line of my paper, I'm going to just drop this in where tangent squared of x is. So remember, the first term, we didn't do anything with it, so I'm just going to recopy that. Don't forget to recopy the negative 2. And remember, we're substituting this in, so let's write secant squared x minus 1 in parentheses. And then bring down your minus 4 and your equal sign and 0. And then, y'all, let's distribute the negative 2. But don't forget, you got to distribute this negative 2 to both things in those parentheses. All right, so 3 secant squared x is just regular. We didn't do anything to that. And then we're going to go to that. We're going to go to that. All right, so it is going to be minus 2 secant squared x. And then remember, a negative 2 times a negative 1 is positive 2. Recopy the rest of the equation. And then look, you have 2 groups of like terms that we need to combine. So 3 secant squared x minus 2 secant squared x is just a plain secant squared x. Positive 2 minus 4 is minus 2. All right, let's move the 2 over. Remember, secant squared, so we're going to have to draw a square root symbol. And what else? Plus or minus. Great job. How many answers are we going to have? Great job. All right. What is secant the reciprocal for? Cosine. There's a root 2 there. What are the radians? What are the only radians that have a root 2 in it? The fourths. So this belongs to the fourths. Let me mute that, y'all. I'm sorry. Okay, 4 answers. So x is going to equal all the fourths. Do you guys have any questions on this? Okay, let's look at problem 2. So for problem 2, I still have sine and cosine. They're different. And I really want to use that top property up there, that one's squared and this stuff isn't squared. Yeah, let's square both sides, guys. Let's square both sides, and then may I please take a moment to remind you to not pull that 14-year-old kid Algebra 1 mistake. 14-year-old kid Algebra 1 mistake would be to just dump this 2 in here. You can't just dump that 2 in there because you have a plus sign. Over here I can dump the 2. Over there on the right side, it is most certainly cosine squared x. You can just put that right in there. But not over here on the left because you have a plus sign. And earlier this week, I asked you to do something like this as a warm-up without showing any work. So I'm going to ask you to do the same thing again. Square that trinomial. No work shown. Can you do it? That's your challenge. If not, you can FOIL it out. So remember, the first term is squared. The middle term, you multiply these together and double it. Sin x times 1 is just sin x. Sin x doubled is 2 sin x. And the last term is squared. So there we go. Okay, so we squared this stuff. I have a lot of sines over here. I only have one cosine over here, so I'm using that trig property. Cosine squared x, remember that's going to equal 1 minus sine squared x. So I'm going to put in that substitution on my next line. Remember, we haven't messed with the left-hand side, so just recopy the left-hand side of the equal sign exactly how it is. But we are changing the right side. We're substituting in. Okay, you guys probably already know this, but I'm just going to say it. No matter what level of math class you're in, geometry, pre-cal, algebra 3, high school, college, whatever, if you have any exponent that you're trying to solve, you have to set it equal to 0, no matter what. So there's a lot of stuff over here. There's only these two things over here, so I am moving this on this side. Okay, so we have 2 sine squared x plus 2 sine x. And these ones cancel. Like, we have a 0 right there. So, what do you feel like is the next thing? Factor the 2 and? Yeah, good job. You recognized both of those. Let's factor out 2 sine x. So when we factor out 2 sine x, we're going to have plain sine x plus 1. And then y'all know what to do. Set each of those equal to 0 and solve. Okay. Where does sine equal 0? I'm recording. That would have been a nightmare. So if it's positive 1 on this side, it's negative 1 on the other side. Thank you very much. Okay, I'm sorry. Where does sine equal 0? Yeah, the beginning and the little sides. So pi and 0 pi. Awesome. And then there's only one place where sine equals negative 1. The bottom. Good. Very good.